Hey guys, this is Spencer Reed here, and today we'll be doing the problem of the integral of sine theta times e to the cosine theta from 0 to pi over 2. And when we first look at this problem here, we have to use u substitution. So we have our u here. And we take a look at this here and we see, okay, can we take this u of this? Well, that doesn't really make a derivative of this. And this will repeat over and over again. So let's use cosine of theta. Sine of theta. Then you take the derivative of it, which is negative sine theta, d theta. And then we look back at the original equation, and we see here these two are not the same, so what we can do is divide a negative 1 on the other side, and we have negative du equal to sine theta d theta. So let's write our integrate again. Now, since we did all this, we can put the e here, since that was not, put into u or du. And since this was u, we can put this right here. And then we can put the du on the outside. And this is all times by negative. And by the rules of integration, we can put this negative on the outside. You have EU times du. Now we take the integral of e to the u, and the integral of any exponential function is just e, and then it's just u. And then we take the negative and we put it here, and that goes from 0 to pi over 2. Now, something we also can do with u substitution, which will help us later, is we can take the limits here and insert it into u. So we have u of 0 equal to cosine of 0, and u of 0 is equal to cosine of 0 is 1, and then we have u of pi over 2 equal cosine of pi over 2. And then we have this again. And then cosine of pi over 2 equals 0. So then we can replace this with 0. Replace this with 1. Then we put back our original equation again, cosine of theta. And then the next step here we will do, let's rewrite our original thing. Since we already did this, we don't really have to plug that in again. That's the greater part of using u substitution. We can just do that, replace the limits, and then we can just do the next step. So the next thing we do is from the highest minus the lowest. So we put negative e to the 0 minus e to the 1 minus. Now, let's see here. A minus and a minus makes a positive. And e to the 0 is negative 1. And e to the 1 is plus e. And that is the answer for the integral of sine theta times e to the cosine of theta from 0 to pi over 2. And the answer is negative 1 plus e.